how to answer procedure, method, and analysis questions. Procedure, method, and analysis questions are very important questions in all papers. I have found that every single paper 1 has at least one 6-mark PMA question, and at least one of papers 2 and 3 have another one. The first and most obvious step to answering these questions is to read the question entirely. In all the physics papers, I found that even the most small details can give you clues as to what the question wants you to say. You want to look for every single variable that it says that you're given, or that it says that you should measure, or that it says it's looking for. A lot of the times in PMA questions, the variables are given in a neat little equation, which will come in handy during analysis. Before you begin writing about your procedure or the measurements you need to do, you need to figure out exactly what it is you're looking for. In 90% of PMA questions, I have found that it wants you to make an equation it gives you, or that you can figure out from context, into the form y equals mx plus c, which is the equation for a line. This is where x and y are the independent and dependent variables, respectively. It's useful because it tells you what you're trying to look for in your procedure, and so it tells you what you're doing with your procedure. And also you can use c and m to, in analysis, find whatever those are, which are typically the thing that the question is asking you about. Sometimes the question won't ask you for a specific number or the value of a specific variable, and it will obscure its intentions behind some other sort of question. For example, in this one, it asks us to test the validity of this equation. Now, we can actually test the validity by proving that the gradient of the line is equal to m over m plus m squared. Now, part of the reason reading the question in its entirety is important is because sometimes the question just straight up gives you the procedure. For example, in this one, it tells you that when you pull up one ball, m, and drop it, it will hit the other one and stick to it. And then when it goes up and reaches its maximum height, that gives you h. So it's basically just told you that you need to find the height of a ball after it's been hit by another ball and they stick together. The more important part of your procedure is telling them how you'd measure the things you need to measure during your procedure. Firstly, I talk about the stuff that you can know without doing any sort of complicated experiment. For example, the masses of these balls, you could just say you'd measure them using electrical scales. Now, when you're writing about this, you have to be incredibly specific about what exactly it is you're measuring and how you're measuring it. For example, don't say you weigh the masses. Say, using electrical scales, measure the mass of masses m and m. When you're measuring the maximum height of a moving object or doing some kind of projectile question, make sure you mention a slow-mo camera and that you have a ruler in frame. There's a lot of other small, specific things that certain questions want you to say whenever you're answering them or talking about a specific measurement technique. I will link a document I have that includes quite a few of them. It's by no means comprehensive, and sometimes you'll just have to use common sense and what you know of the measuring method in order to be able to figure out what it is that someone might want you to say about for them. Once you've measured everything you can and you've outlined the procedure, you just write down the equation, your y equals mx plus c equation you figured out earlier, and say that you plot a graph of y over x, draw a line of breadth for it, and determine the gradient of the line with a big triangle. I don't know why, but I've seen in a fair number of questions that they want you to specifically say you determine the gradient with a big triangle. They also want you to mention if the line of best fit will go through the origin. That can be figured out pretty much just if there isn't a plus c, or if plus z is 0, that means the line's going to go through the origin. Now, the last thing you've got to do is to figure out how you would calculate whatever it is you're trying to find using the gradient or using the y-intercepts. This isn't a great example for that because there's no real calculation I need to do since I'm not actually trying to find anything with the gradient. I'm just trying to prove that it works, or that m over m plus m squared equals the gradient. Also, finally, a lot of questions would ask you to do repeats of the same value with the independent variables, so drop the mass from the same height each time and get a mean, or drop mass from variable heights and get a mean. That's just a sort of accuracy thing, and it helps out in quite a few questions. A lot of times you won't get marks for saying that, but you'll never get marks taken away for saying it, so you might as well throw it in there. Also remember that for other kinds of questions, you might want to include diagrams, because if you put them and they're legible and they're properly labelled, you will get marks for them, or at least you'll help the examiner understand what you're talking about, which will make them more likely to give you marks. This is particularly useful for circuit-style questions. Whenever you do a circuit-style question, don't describe the circuit with words, draw a diagram. It'll save you so much time, and it'll be so much more understandable. In the description, I put a link to a Google Doc containing all of the common points for ensuring accuracy for each type of measurement, as well as several other little points that they really want you to talk about in certain exam questions, when you talk about certain procedures that you've done in school. I've also included a list of PMA questions which I've ranked by difficulty. Please do try at least a few of the more difficult ones, because it'll be great practice and it will really help you out. Best of luck in your physics exams, and let me know if there's any more exam-related content you'd like me to cover.